Welcome to my lecture. Today we are going to solve a tutorial problem in engine force analysis. Let me read the problem. The lengths of crank and connecting rod of an engine are 200 mm and 1 meter respectively. The crank is rotating at 400 rpm. When the crank has turned through 30 degrees from inner dead center, the difference of pressure between the cover and piston rod is 0.4 Newton per mm square. If the mass of the reciprocating parts is 100 kg and the cylinder bore is 0.4 meter, calculate inertia force, piston effort, thrust on sides of the cylinder walls, thrust in the connecting rod, crank effort, and turning moment. Okay. First of all, we need to identify whether the engine which is given in the problem is a horizontal one or a vertical one. So here there is no mentioning of exactly whether it is horizontal or vertical in the problem. But here we are given with the data that is inner dead center. Okay, it refers the engine is a horizontal engine. Okay, so first let us write down the given data. Okay, before moving on to writing the given data, so let us draw the configuration of a horizontal reciprocating engine. Okay, so here this is the system which is given as far as this problem is concerned. Okay, first the length of the connecting rod is 1 meter. Okay, so here the length of the connecting rod is 1 meter and the radius of the crank is 200 mm. Okay, so the radius of the crank is 200 mm. So we can convert that into meter. Okay, and then the crank is rotating at a speed of 400 rpm. Okay, it is rotating at a speed of 400 rpm. So the n value is 400 rpm. Okay, and theta is 30 degree. That means the crank has turned through 30 degree from inner dead center. Okay, so theta is equal to 30 degree. And here the pressure difference is given, that is difference of pressure between the cover and piston rod is given, that is 0.4 Newton per mm square. Okay, so the difference of pressure means it is P1 minus P2 which is equal to 0.4 Newton per mm square. So if you want to convert that into Newton per meter square, what you need to do is 0.4 multiplied by 10 to the power 6 Newton per meter square. Fine. Okay, then the mass of the reciprocating parts is given. What is the mass of the reciprocating parts? It is the piston mass. Okay, so the reciprocating parts means it is piston. So the MR value is 100 kg. And then we are given with the bore value, that is the diameter of the cylinder, that is 0.4 meter. Okay, so this value is given, that is the capital D is equal to 0.4 meter. That means the piston is just sliding within the cylinder. Okay, so this diameter value is given, it is the bore dia. Okay, but we are not provided with the dia of the piston rod. Okay, so in the problem we are not given any value corresponding to this value. D value is not provided as far as this problem is concerned. Okay, so we are going to find out first the inertia force, that is Fi, and then we are going to calculate what is the piston effort. Okay, and third we are going to calculate what is the value of thrust on sides of the cylinder walls, that is Fn, and then we are going to calculate what is thrust in the connecting rod, that is Fq, and we are going to calculate what is crank effort, that is Ft, and then we are going to calculate finally the value of turning moment. Okay, now let us see how to solve the problem. Okay, fine. The first thing we need to know is the angular velocity of the crank, that is omega is equal to 2 pi n divided by 60. Okay, so which is equal to 2 pi n is 400 rpm divided by 60. Okay, so this value is 41.89 radian per second. Okay, This is the initial value that we need to calculate. And then we must know what is the value of the ratio between length of the connecting rod to the radius of the crank. Okay, L by R. So which is equal to 1 by 0.2, which is equal to 5. Okay, these are all the things are initially calculated. Okay, and then first thing we need to find out is, so we are going to calculate the inertia force. Okay, we are going to calculate the inertia force. So what is the formula for finding inertia force? It is mass times acceleration. Okay, Fi is the mass of the reciprocating parts multiplied by R omega square cos theta plus cos 2 theta divided by n. Okay, this is the formula to find out the inertia force. Okay, so we know that the mass of the piston, that means the reciprocating parts, is 100 kg. So R is 0.2 and omega is 41.89, that's p square, and then cos 30 plus cos 2 times 30 divided by n value. So n value is 5. Okay. So now by solving this equations, then we can find out 33.903 kilonewton. Okay, so by substituting this value, so we can calculate what is the inertia force is. So the inertia force is 33.903 kilonewton. Okay, fine. And then we are going to calculate the force, that is which is acting on the piston. We can call that as piston effort. Okay, so if you want to find out the piston effort, before that we must know what is the force which is acting on the piston due to gas pressure, due to gas pressure. So if you know this value, then only we can find out the net load on the piston, that is piston effort. Okay, so let us find out the gas load. So we call that as FL. Okay, so because we are asked to calculate the piston effort, so while finding the piston effort, we are in need of this value FL. Okay, that is force due to gas pressure. Fine. Okay, so how to find out this value, that is FL? So we know the formula. Okay, to find out the gas load, that is P1A1 minus P2A2. Okay, this is what the formula that we know, P1A1 minus P2A2. Okay, so this is the formula, general formula for to find out that value. But as far as this problem is concerned, a value is not provided, that is small a value is not given. Okay, it is not given. Okay, so I don't know exactly what is the a value is, so I'll just take a1 is equal to a2, which is equal to a. Here, so this value is not given, that is the rod dia is not given, so I'm just going to take that as 0. Okay, so a value is not given, so I'm just going to take this value as 0. So obviously this a1 and a2 is going to be same. Okay, that I'm just going to take it that as a. Now this equation is changed into p1 minus p2 multiplied by a, because these two terms are equal to a. So I'm just taking a outside. So this equation becomes p1 minus p2 multiplied by a. So if this value, that is the diameter of the piston rod, is given, so what you need to do is we need to find out the a2 value. Okay, 2 is a1 minus a. Okay, that is what the thing. Okay, since a value is not given, so we have taken that as a 0. So a2 is equal to a1, which is equal to a. So now we have just got this formula to find out the load which is acting on the piston due to gas pressure. Okay, fine. So P1 minus P2 is here we got that value 0.4 into 10 to the power 6, and this value that is A, can be found by applying this relation pi by 4 d square. Okay, this is what the bore diameter, this dia. So that value is 0.4. Okay, fine. So by substituting this value, we can find out exactly the load which is acting on the piston due to gas pressure. Okay, it is equal to 50.265 kilonewton. Okay, fine. So now we have calculated what is the exact value of inertia force and what is the value of load which is acting on the piston due to gas pressure. Okay, so now we are going to calculate the piston effort. Okay, it is the net resultant force. Okay, piston effort, that is FP. It is the resultant force which is acting on the piston along the direction of the motion. Okay, so we know that FP is FL, okay, minus FI minus FF. Okay, this is the formula to find out the piston effort as far as horizontal engine is concerned. Okay, so what you have to do is we need to know what is the value of load due to gas pressure, and then what is the value of inertia force, and then what is the value of frictional resistance. Okay, so as far as this problem is concerned, it is not provided. Okay, the frictional resistance value is not provided, so I'm just going to take it as 0. Okay, so the equation becomes FL minus FI. So it's very simple. So this value I have just already calculated, F50.265 into 10 to the power 3 minus, and this value is already calculated, 33.9 multiplied by 10 3. Okay, so this is the value of yeah. Okay, so this value is 16.36 kilonewton. Okay, so the piston effort is calculated, which is equal to 16.36 kilonewton. Okay, so this equation we have done a simple modification because the frictional resistance is not provided. As it is not given, we have taken that as 0. Okay, and the next value that we are going to calculate is thrust on the sides of cylinder walls. Sides on cylinder walls. So that is the reaction force. That is the reaction force. Okay, so that value can be found by applying this formula. Fn is Fp tan phi. Okay, so here we happen to see one term, that is phi. Okay, so it is the angle between the connecting rod to the line of stroke. Okay, but we only know what is the value of theta. Okay, how to find out the phi value? So we need to apply this relation, sin phi is equal to sin theta divided by n. Okay, sin phi is equal to sin theta divided by n. Okay, so by applying this theta value, we can find out the phi value is 5.74 degree. Okay, 5.74 degree. Okay, so now we can apply this value here and we can find out what is the value of FP is. Okay, straight away I'm just writing the answer because we know what is FP and what is phi. Okay, if you substitute this value, we can get what is the value of thrust on sides of the cylinder walls. Okay, it is 1.644 kilonewton. Okay, fine. And the next question is we are going to calculate the thrust on the connecting rod. Okay, thrust on the connecting rod. Okay, so this is FQ. Okay, this is FQ. So the formula to find out this FQ value is Q is FP divided by cos phi. Okay, so here also we know the FP value and phi value, then straight away we can just write the answer, which is equal to 16.44 kilonewton. Okay, and the next values we need to find is, one is crank effort and the another one is tanning moment which is acting on the crankshaft. Okay, so how to find out those values? So crank effort is represented by Ft. Okay, so which is acting exactly perpendicular to the crank and which generates the necessary turning moment at the crankshaft. Okay, so this value can be found by using the relation Ft is equal to Fp divided by cos phi sine theta plus phi. Okay, this is the relation to find out the crank effort. Okay, so we know the value of Fb and theta and phi. Okay, so straight away if you substitute these values, we can get that crank effort, that is 9.605 kilonewton. Okay, this is the value of the crank effort. Okay, and finally we are going to calculate what is the turning moment. Turning moment value. Okay, that is T. The simple relation is T is equal to Ft multiplied by R. Okay, because it is that if you take this as a crank, so this is the angle theta is equal to 30 degree. Okay, this Ft is going to be acting in this direction, that is Ft. Okay, so this is the length of the crank. Okay, so the turning moment is found by multiplying this Ft with the radius. It is very simple calculation. So by doing so and getting this value of turning moment, so 1921.13 Newton meter. Okay. So in this tutorial, we have seen how to calculate the inertia forces and how to find out the gas load which is acting on the piston, okay, because of the pressure during the power stroke. And by using these two values, we have calculated what is the net load on the piston, that is the piston effort. We have calculated this value, okay, by applying this FL and FI. And then once you know the FP value, then we can find out all those other values very easily. Okay, but another term which is required to be found is phi value. So that can be found by using this relation. So we need to remember this equation, that is sine phi is equal to sine theta divided by n. So now phi value is also found. By using that, we found thrust on the sides of the cylinder walls, thrust on the connecting rod, crank effort, and turning. Okay, thank you.